Hello, grade 8. So this week we started with a new chapter called Literal Fractions. Okay, so moving forward from the slide, you have to copy everything on your copybooks. So let's start with the definition, literal fraction. And before we define literal, let's define a fraction. So we did a little activity in class where I asked the students to count how many students we have in class. And let's say we got around 30 students. And then I asked, count the number of girls in this class. And maybe it was around like 12. And like count the number of boys in this class, and it was around 18. So here are the boys. So the first fraction, it represents girls. The second one, it represents boys. So I have 12 girls out of 30 students and 18 boys out of 30 students. So we are familiar with the fraction already. 12, it is the numerator. 30, it is the denominator. And we can simplify a fraction, right? We can write it in its simple form. So how can we simplify this fraction? We take a look at the 12. Is it divisible by 2? Yes. Is the 30 divisible by 2? Yes. So 12 divided by 2, it's 6 over 15. Now, is the 6 divisible by 2? Yes. Is 15 divisible by 2? No. So we cannot divide by 2. Let's start with 3. Is 6 divisible by 3? Yes. 15? Yes. And this is 2 over 5. So 2 over 5, I have 2 girls in every 5 students. So that's really nice. And we can do the same thing for the fraction of boys. Okay, so we can simplify it as well. Now, of course, we can use a calculator to help us simplify a fraction, but I need to see that you are dividing by some numbers. Like I need to see what you are doing with the fraction. Okay, so we're done with the word fraction. We already know about this since maybe grade 5 and 6. Now let's start with the word literal. Literal fraction, it means that this fraction that we see, okay, it contains not only numbers, but maybe some letters, all right? So it contains a variable or many variables, and these variables are written as letters, for example, these. Okay, so if we take a look at this fraction, can I simplify it? Yes, I can because I have b in the numerator and I have b in the denominator, so this fraction becomes 2a over 3. Great. Another thing about fraction is that a fraction cannot be, the denominator cannot be equal to 0. Okay, so it can be any number but 0. It cannot be equal to 0. Now, if it's only numerical fraction, of course, I'm gonna be able to, know what I have in the denominator, like it's always a number. But in case of a literal fraction, sometimes we have some letters in the denominator. And in this case, like we have b. So there is a condition on b. B cannot be equal to what? It cannot be equal to 0. It is different from 0. Because if it's equal to 0, then 3 times 0 is 0, and then you'll have 0 in the denominator, and it's impossible. We can't do that, okay? All right, so as we just mentioned, the definition is that a fraction containing variables denoted by letters is called a literal fraction. It is defined when its denominator is not 0. Here are examples of literal fractions. Just take a look at them. All right, I cannot simplify these because they are already simplified. Now there is a little note about fractions in general. Okay, so if you have minus negative a over b, it is the same as a over negative b, and it is the same as negative outside the fraction a over b. Of course, b should be different from 0. Okay, so if I want to give an example, so negative 1 over 2, it's the same as 1 over negative 2. It's the same as negative 1 over 2. which is negative 0.5 if I want to find, the decimal form of this fraction. So all of these, they give the same answer. The answer is negative. Okay, so I can move this negative sign around. I can put it outside the fraction. I can put it in the numerator. I can put it in the denominator. Now I want to ask you something. What if I have negative 1 over negative 2? What happens to the two negatives? So they cancel each other. All right, it becomes 1 over 2, which is positive. And this is the second note. If you have negative a over negative b, it becomes a over b. And of course, b is different from 0. Okay, moving on to simplifying literal fractions, which we already talked about. So let's just start. Okay, so it means dividing the numerator and the denominator by the common factor. So if there is a common factor, if there is a letter that is repeated in the numerator and in the denominator, we can divide by it and we can simplify the fraction. I'm going to give an example now. Okay, so this is an example. It says simplify. Starting with the first one. So how can I simplify this one? You can see that if I divide it by 2 in the numerator and in the denominator, I'll get 1 and 1. So the answer is x over y. How about number 2? I have 2 and I have 4. I have different letters, so I can't simplify with the letters, but I can do it with the numbers. So divided by 2 and this one divided by 2, this becomes 1 and this becomes 2. So the answer is a over 2b. The third one, x with x, y with y. And if I divide it by what? I can divide by 2, but in the denominator I have 3, so I can divide 3 by 2. So I can divide by 3 and by 3 here it becomes 1 and this one becomes 2. So the answer is just 2. And number 4, I have a and a, so the answer is b plus 5 over b minus 2. Now, there is a common mistake that students made in class, which is that some students, this b plus 5 over b minus 2, some students simplified these two letters together. Now, there is a condition for simplifying fractions. The numbers need to be multiplied by each other. I cannot simplify it when I have addition or subtraction because it doesn't make any sense. If I multiplied by b and I multiplied by b, I'll get b plus 5 over b minus 2 over b. Look at this. So it's gonna just get us back to square one. It's not gonna make any sense. We won't be able to simplify anything. So it doesn't work. I cannot simplify this, okay? But what I can simplify, if I have a into c plus 2 over b into c plus 2. So if the expression is all included in the parentheses, in the numerator and in the denominator, same expression, okay? And of course, there is an invisible multiplication between letters and numbers if you don't see it. For example, 2a is actually 2 times a. For example, ab is actually a times b, all right? Now, in this case, c plus 2 and c plus 2, they cancel each other, and the answer is a over b. Why did I simplify these? Because they are all included in parentheses and it's the same. I have identical parentheses in the numerator and in the denominator, and this parenthesis is multiplied by all the other numbers or letters in the numerator and the denominator, okay? But if I have, let's say, 1 plus a into c plus 2, I cannot simplify these because now I have addition in it. Okay, so we cannot simplify if we have addition and subtraction just anywhere in the fraction, all right, unless all the expression is in one parenthesis and it's exactly the same as the expression in the denominator, so we can cancel it. I gave a really nice example for students in the class. I'm going to give it here. So if a times pizza, okay, because we were hungry, over b times pizza, okay, and this pizza, it can contain everything. It can contain cheese, vegetables, I don't know, olives, the pepperoni, anything. All right, we can cancel pizza with pizza. There you go. And the answer becomes A over B. Okay, so as long as all the expression is put in one parenthesis and it is repeated in the denominator, and the whole sentence, the whole multiplication sentence it contains only multiplication outside the parenthesis, then I can cancel them. Okay. Now we're going to start with operations on lateral fractions. Okay, so addition and subtraction. We already know in fractions, if we have, let's say 1 over 2 plus, I don't know, 4 over 2. Since we have same denominator, these are called like fractions, and we just add the numerator. So 1 plus 4 over 2, which is 5 over 2. This is how we do it. Now, if we have different denominators, let's say 1 over 2 plus 4 over 5, I cannot add the numerators in this case. So what do? I need to make them like fractions. I need to make the denominators the same. So I multiply, the denominator for this one is 5. So I multiply by 5, the denominator and the numerator. And this one is 2, so I multiply by 2. All right, and the answer is 5 plus 8. And now we have the same denominator, which is 10. So we can add the numerators. 5 plus 8, it's 13 over 10. So this is how we solve. This is how we solved fractions from before. Now it's the same thing, but the only difference, of course, that the expression might contain, you know, it might contain some letters. So the property says if I have A over C plus B over C, the answer is A plus B over C, because these are like fractions, so they have the same denominator. Now, if they don't have the same denominator, we need to make them have the same denominator. Sometimes you can multiply one of the fractions by a number so that it is the denominator of one of the fractions by a number so that it is equal to the other one. I'm going to give a case. I'm going to give an example here. If I have 1 over 2 plus 3 over 4. Now, I first take a look at the denominators. Are they the same? No, they are not the same. So can I make one of them equal to the other if I multiplied it by something? So yes, if I multiply the 2 by 2, it becomes equal to 4. Great, so I multiply in the numerator and then the denominator, and I don't do anything to the 4. So the answer is 2 plus 3 over, now they have the same denominator, which is 4, so it's 5 over 4. Okay, so in the first case, it was half plus, let's say 3 over 5. Here, the two denominators, they are completely different. I cannot make the 2 a 5, so I cannot make the small number equal to the big one. This means that I need to multiply both fractions. But in this case, it is okay. We can multiply only one fraction because I can make the denominator equal to the other one if I multiplied it by a number. Same thing with literal fractions. Let's take a look at the first one. So we have A over C plus B over CD. So I have C and CD. Can I multiply one of them by something so that it becomes equal to the other? Yes. So if I multiply the first one by D, it becomes CD, which is equal to the CD. All right, so the answer is AD plus B over CD. The second one, I have y and I have 2y. Can I multiply one of them so that it becomes equal to the other? Yes, I can multiply the first one by 2. It becomes 2y also. Okay, so the answer, for x times 2, we multiply the number by the number. So 4 times 2, it's 8x minus 7 over 2y. The third one, m and n, can I multiply one of them, one of the denominators, and it can become equal to the other? No, these are completely different, just like these. So what do? We multiply both fractions. So the first one, is multiplied by n in the numerator and in the denominator. The second one is multiplied by m in the numerator and in the denominator. So the answer is 2n plus tm equal divided by or over mn. Number 4, we have 2a and t. These are also completely different. I can't multiply one of them, so that it becomes equal to the other. So same thing, we multiply both fractions, the first one by t in the numerator and in the denominator, the second one by 2a. So the answer is t plus t minus 6b times 2a. We multiply the number by the number, so 6 times 2, it's 12ab, all right, over 2at. Number 5, when you have a number and it doesn't look like fractions, so this means a over what? It's a over 1. Great, so we multiply it because it's 1. All right, so we'll multiply it by 7b in the numerator and in the denominator. And the second one, there's no need to change anything about it. But the whole point is that it needs to be multiplied. It doesn't need to be multiplied because I can make the 1 equals to 7b by multiplying it by 7b. And the answer is 7ab plus 8 over 7b. Now, some students ask me why a times 7b, why it's not equal to a 7b? Because we always write the number first and then we write the letters. Now, part 6, I have two denominators. One of them is 2a squared, the other is 2a. The question is, can I multiply one of them by something that it becomes equal to the other? Yes. What can I multiply this by? How can I make the a equals to a squared? I need to multiply it by another a. So I multiply by a, and the answer is b minus ca over 2a squared. Moving on to the multiplication. Guys, like the addition and subtraction are the most difficult part in this chapter. So multiplication and division, they are very simple and very easy. Multiplication, if I have a over b times c over d, we multiply the numerators and then over the multiplication of the denominators. We don't take a look at the denominators if they are like or not alike. All right, why? Because it doesn't matter, I will multiply them. Some students make a mistake thinking or having this, being confused by the multiplication, so they think it's addition and they start multiplying this by d and this by d and this by b so that they can have the same denominator. Please don't do that, okay? This is multiplication, it has its own rules, it's not addition, it's not subtraction. There is a little note though. It says that simplify before multiplying, okay? For example, I'm going to give an example. If I have 1 over 2 multiplied by 4 over, let's say, 6, okay? I can multiply them like 4 over 12 and then I can do simplification. Or I can simplify before I multiply. So 4 divided by 2 becomes 2. This is divided by 2 it becomes 3. So the answer is 2 over 6. There you go. Okay, and now I can also multiply. I can simplify it again. It becomes 1 over 3. Great. Another example. Let's say I have 3 over 5 times 5 over 2. Okay, in multiplication, you can consider all the numbers in the numerators, both of them, 3 and 5, as if they are in the same numerator, and the numbers in the denominator as if they are in the same denominator. So I can even simplify 5 by this 5. See? So it becomes 3 times 1, which is 3, and 1 times 2, which is 2. So I can do that as well. Okay, let's start with an example. We have a over b times 3 over c. So it is 3a over bc. The second one, 2x over y times 3 over 2. It becomes 6x over 2y, or I can simplify 2 with 2. So I have x times 3, which is 3x over y. See, you can write it as 6x over 2y. It's still correct, but then you need to simplify. Okay, so this becomes 3 and this is 1, so it becomes 3x over y. Okay, now number 3, 6y over m times t over 1. So 6y times t, it's 6yt over m, okay, because this one becomes over 1. Number 4, see, this is what I was talking about. Here, it's important to simplify before we multiply because you have so many letters, so many numbers. So if you simplify before, the expression becomes very, it's very simple. Okay, so let's start with the letters. I can simplify m with m, right? Numerator and denominator. I can simplify n with, I have n squared, so I can get rid of one of the n's and still have the other. Now, how about the numbers? It is minus 2 times, and I have 4 and over 6, so I can simplify the 2 and the 6. So I have 1 instead of 2, and minus 1, of course, and 3. So now the expression is minus 1 times 4n, which is minus 4n, over 1 times 3t, which is 3t. All right, division. Division is very simple, and as long as you know multiplication, you will know how to do division. A over B divided by C over D. I need to change the division into multiplication, all right? But when I do that, the fraction that comes after the division, I need to write its reciprocal. Reciprocal, it means the numerator becomes the denominator and the denominator becomes the numerator. So C over D becomes D over C. And now we do normal multiplication, AD over BC. Now, what is the reciprocal of A over B? It's B over A. Of 1 over B, it's B over 1, which is B. How about of A? As if it's A over 1, it becomes 1 over A. Let's do this example. The first one is m over n divided by c over n. Guys, we cannot do any simplification when we have division. We have to change it into multiplication, and then we can simplify. So this becomes multiplied by n over c. Now we can do simplification, and the answer becomes m over c. The second one, x over y divided by x over y. Again, I need to change it into multiplication. It becomes x over y multiplied by y over x. Now I can simplify the x's and the y's because I have x in the numerator and x in the denominator. And the answer is 1 over 1, which is 1. The third one, x over y divided by y over x. Remember, we cannot simplify yet, so we need to change it into multiplication, multiplied by x over y and not y over x. Now, what is x times x? It's x squared. What is y times y? It's y squared. Number 4, 3a over b divided by a over 2. It becomes 3a over b multiplied by 2 over a. I can simplify the a and the a, so the answer is 6 over b. And number 5, 3a over 5b divided by 6a over minus 10. We can change that into multiplied by minus 10 over 6a. Guys, we can do the, I can simplify the letter A with A. Now the numbers, I'm going to keep them for now. I'm going to show you that we can keep them and then simplify at the end as well. So 3 times minus 10, it's minus 30 over 5b times 6. So 5 times 6, it's 30b. Now I can simplify 30 with 30. Okay, we can divide by 30. Numerator in the numerator and denominator, it becomes minus 1 over b. And number 6, 8m squared over 12 divided by 4m squared over what? It means over 1. So it becomes multiplied by 1 over 4m squared. Now I can simplify m squared with m squared, right? I can also simplify divide by 4, it becomes 1. Divided by 4, it becomes 2. Okay, so I have 2 over 12. Can I simplify also again? Yes, the 2 becomes 1 divided by 2 and 12 becomes 6. So the answer is 1 over 6. Now moving on to a different chapter. Actually, these both chapters are like two parts of the same chapter. So this one is called compound fractions. Okay, so what is a compound fraction? A compound fraction is the fraction whose numerator and denominator are fractions. So this is an example. I have a fraction in the numerator and I have a fraction in the denominator. All right, so this a over b, this whole fraction is the numerator, and c over d is the denominator. Now, how can I solve this one? Guys, the solution is much, much more simple than you expect. How to calculate a compound fraction? It is simply division. Okay, so we can do it this way. As if I'm saying a over b divided by c over d. A over b divided by c over d. So I change the division into multiplication and then I multiply normally. So we can do it that way. The other way to do it, which is a bit easier, so we multiply the two numbers that are far, very far, the two far numbers, and I multiply the two near numbers. The far numbers a and d are put in the numerator and the near numbers are put in the denominator. I'm going to give an example. Okay, so I'm going to give an example before I move on to the note. Let's say I have 1 over maybe 5, or let's make it 2 over 5 over 3 over 10. Okay, and I'm going to give another example, which is, let's say, 5 over 2 over 10 over 3. Okay, I want to solve this one. So I can multiply the two numbers that are far. 2 times 10, it is 20 in the numerator. And 5 times 3, it is 15. Now I can simplify. Divided by 5, both of these, they become 4 over 3. Okay, by 5 and by 5. Great. I have another way to do it also. I can simplify before I do this. But how can I simplify? Guys, you can simplify numerators or denominators. So I look at the 2 and the 3. Can I simplify these? Can I divide them by something? Do they have any common factor? No. How about the 5 and the 10? Yes, I can divide both by 5. So if I simplify this one, it becomes 1. If I divide it by 5, this one becomes 2. Now I can multiply. Now I can continue the compound, the calculation of the compound fraction. So 2 times 2, it's 4. Over 3 times 1, it's 3. There you go. The answer is already simplified. So this is one of the notes. The other note is this one. I can also simplify the numerators, not only the denominators. So divide by 5, it becomes 1. And by 5, this one becomes 2. So again, 1 times 3, now it's 3. 2 times 2, it is 4. So these are the two notes. The first one, it says that we can simplify denominators if possible. Okay, so we can cancel letters. We can simplify denominators before we do the multiplication. Okay, and also we can simplify numerators if possible, also before doing the multiplication. Okay, so this is an example. The first one, 3 over a over 2 over b. So let's take a look at the numerators. 3 and 2, can they be simplified? No. A and b? No. So let's do multiplication. 3 times b over a times 2. So 3 times b is 3b over 2a. The second one, let's take a look at the numerator. 4 and 5 cannot be simplified. 3 and 2 cannot be simplified. So let's do multiplication. 4 times 2 over 3 times 5, so it's 8 over 15. The third one, how about a and a square? Yes, I can simplify here. Okay, so I can do simplification. How about b and c? No. So now we do multiplication. It becomes A times C, sorry, it becomes 1 times C, which is C, over B times A, which is BA. Number 4, B over 2A over 2C over A. Numerators, B and 2C. I cannot simplify. Denominators, 2A and A. Yes, I can simplify. A goes with A. Now I do the multiplication. So B times 1, it's B, over 2 times 2C, it's 4C. So the answer is B over 4C. And number 5, 3M and M. Yes, we can simplify M with M. N and 4, no, we cannot. So 3 times 4 over N times 1. So it becomes 12 over N. And that's it. A worksheet was distributed. It contains all the exercises that we need to solve in these 2 chapters. Study well, practice them, and yeah, take care. Bye-bye.